All right, welcome to topic 1.3, adding and subtracting with significant figures. So last week we worked on how to count significant figures and then how to also count significant figures and then round to a set number. And that's going to impact today where we start looking at how do we keep significant figures within calculations. So today we're going to look at the rule that applies to adding and subtracting. And then tomorrow we'll talk about the rule for multiplication and division because they are very different from one another. So this is the long-winded version of the rule for how to add and subtract. Essentially, you have to look at how many significant figures are in the decimal portion of the value, and that you can never have more significant figures than your least precise number. Or what I mean by that is your least or fewest significant figures to the right of the decimal. So that's going to make more sense as we apply it with examples. So this first problem that we are going to take a look at is 25.1 grams added to 2.03 grams. So you can do the Atlantic Pacific rule. Both of these are Pacific because decimal is present, so as you go from left to right, each of these should have 3 significant figures in the whole entire number. Now for addition and subtraction, what we care about is how many of those significant figures are in the decimal. So as you do that rule, 1 significant figure is in the decimal, and in 2.03, 2 of those values are in the decimal. So it asks which number has the least number of digits to the right of the decimal. And what I mean by digits is fewest significant figures. So that number is the 25.1 because it only has 1 significant figure. So how many significant figures does it have in the decimal part? That is 1. So your final answer is limited to 1 decimal place because of your value with the fewest significant digits in just the decimal portion of the number. What's to the left of the decimal does not matter. So if you run this through on your calculator and add the two, so take 25.1 plus 2.03, you get an answer of 27.13. Now we need to round this to the correct number of significant digits. And we said in this previous point that we can only have 1 decimal point. So this 27, that's going to stay with us, but all we can keep is this tenths place. So the last part is, does this round? It does not. So our final answer is 27.1, and if you really want to get nitpicky, you could put grams on there. And that's our final answer rounded to the correct number of significant digits. So here's a few more practice problems. So in example A, we have 1.3 added to 10.176. The first thing I recommend that you do is you need to count how many sig figs are in the decimal. So if you do the Pacific rule here, this has 1 sig fig in the decimal. 10.176, all 5 are significant, so 3 of those are found in the decimal. When you do this addition, you are limited to the fewest number of sig figs, which will be 1. So go ahead and grab your calculator and add these up. So 1.3 plus 10.176. When you do that, you should get an answer of 11.476. Now we need to round to the correct number of significant digits. Again, what's ever to the left doesn't impact it, so we can go ahead and say 11. We can only keep the tenths place, so you have to look at what follows, which is the 7. That 7 will round. So our final answer to the correct number of significant digits is 11.5. Here we have 3 values being added together. 12.52 has a total of 4 sig figs. 2 are in the decimal. 349.0, so you still do the Pacific rule, go left to right. So that 0 is significant, so that has 1 in the decimal point. And 8.24, the 24 is going to be significant with the Atlantic Pacific rule. So we are left with 1 sig fig again, because that's our fewest. If you add these up, you get an original grand total of 369.76. You can only keep 1 decimal. Looking at what follows, it's a 6. That's going to round it up your final answer should be 369.8. In this next one, we have 9.44, 3 total sig figs, 2 of which are in the decimal. 2 meters, there is no decimal point in this value, so there is none. So you cannot have a decimal in your final answer. So when you subtract these two, you get 7.44. Again, because this 2 meters has no decimal point, this part needs to go. So the last thing we need to look at is, does this round up to 7? It will not. So your final answer to the correct number of significant digits is 7. The last example, 34 minus 17.390. Doing the Pacific rule, these are all significant, so that means one of them is found in the decimal. This next value is also Pacific, so it has a total of 5 sig figs, 3 of which are in the decimal. That means we are limited to 1. When you complete that subtraction, you get an answer of 16.61. When you go ahead and round to your final answer, we can only keep 1 decimal point. That 1 is not going to round us. So our final answer is 16.6. So I have 4 more problems. What I would prefer for you to do at this point is pause the video and try these out on your own, and then see how your answers compare. So again, take a second to pause the video. So hopefully you took a second to pause and work these through. When you added these two together, this one has 2 in the decimal point and none. When you added it up, you originally get 7.6. You cannot have a decimal point in your answer because of the 0. So your final answer is 8 because of rounding. Adding up these, be very careful here. These are both Pacific. Do your Pacific rule. This only has 1 sig fig in the decimal. This one has only 1 sig fig. They're limited to the same number, so we can only have 1 sig fig in our final answer. When you originally add these together, you get 0.058. As you do that Pacific rule, these zeros aren't counting. The 5 is the first point in which the decimal is counting. That 8 does round up. So we get an answer of 0.06 for our final answer. Here, we have 4 significant figures in the decimal point, and this one has 2. You're limited then to your fewest number of significant digits, which again will be 2. So when you go ahead and add these up, you get an answer of 79.422. We just said 2 decimal points, so we can keep the 4 and the 2. This 2 does not round up. Our final answer is 79.42. Lastly, we have 67.5. This has 1 sig fig in the decimal, and 0.009, again, is only 1 significant digit in the decimal point, so we can keep 1. When we do the subtraction step, you get 67.491. The 67 can stick around. We can only keep 1 point in our decimal, and we are going to have rounding take place. So our final answer here is 67.5, which looks a little goofy because that's where we originally started out with. And so that's where things get a little bit different with our rules with addition and subtraction with decimals. Just like any other time, if you have any questions over these practice problems or need more assistance, please reach out to me.